Hi guys, again, this is Mr. E here with part 2 of 10-5, which is we're learning how to find the perimeter and area of composite figures. The second part of this video, we're going to learn how to find the area of a composite figure. Alright, so what does it mean to have a composite figure? Alright, so it's a shape or a figure that can be divided into more than one basic shape. All right, so think about it like this: here we have a complex shape, but in reality, if we break it down, we have two simple shapes: the rectangle on top and then the rectangle at the bottom. You can also break it down into three shapes. For this, you can do the rectangle in the middle and possibly the two squares on the sides. Yep, it looks like it would be two squares. You could even break it down even further. You could have a total of two rectangles in the middle and then two squares on the sides. But let's just keep it simple. Let's just break it down two simple shapes: the rectangle on top and the rectangle on the bottom. So again, a composite figure is a shape that can be divided into more than one basic shape, and here in this case we have two basic shapes, two rectangles. All right, so if you want to find the area, all right, so if you want to find the area, let's just simply start by finding the area of the rectangle on top. Again, area of this rectangle would be length times width, so 2 times 3, which is a total of 6 centimeters squared. So that is the area for the rectangle on top. And then the area for the rectangle at the bottom would be 2 times 7, because again, length times width. That's a total of 14 centimeters squared. So for the area is 6 centimeters squared plus 14 centimeters squared. So 14 centimeters squared plus 6 centimeters squared. That's a total of 20 centimeters squared. So that's the area of this composite figure here. All right, so if you want to find the perimeter, we would add all the lengths that we have here. Again, just be careful. Some of the lengths are not represented or are not written on here, so I would write them down if you're not sure, so you don't miss it. So let's start with the blanks here. This is 2 because this other length here is 2. This is also 2 right here because this other length here is 2. And again, it's a rectangle, so it makes sense. And again, the way we know it's a rectangle is because we have 4 90-degree angles here. And same thing up here. We got 4 90-degree angles here, so we got 2 rectangles. So we have all the blanks that are missing. We can add all the sides together. So we just got to add all the pieces. Let's start at the top. You got 3, 2, 2, 2, 7, 2, 2, 2. Took care of all the sides. If you add them all together, that should be a total of 22 centimeters around that composite figure. All right, moving on to this last example here. We got to find the area of the shaded space. All right, so again, there's several ways to doing this. The way that I recommend is finding the difference between the two shapes that we have here. I would say that splitting this into 2 problems would be the best. So let's start off with finding the area of this rectangle here. So area of the rectangle, the bigger shape here, is going to be, again, base times height. And the base and the height for this rectangle is 9 and 8. So 9 times 8, 72 centimeters squared. So if we were just asked to find the area of that rectangle, then it would be done, but we want to find the area of this shaded region. So just this part, the shaded region that we have there. So we have to subtract that L looking shape that we have here. All right, so we got to find the area of, essentially, just call it L. So area of L. All right, so here we have two shapes. Again, it's a complex figure. It's a composite shape. Let's break it down into two shapes that we know. All right, so again, just break it down this way. So here we have two rectangles again. Let's find the area of the bottom rectangle first. Bottom rectangle will be length times width, so 4 times 2, which is 8 centimeters squared. And then we know that if you want to find the area for this top rectangle there, so let's see. If we know that this length is 2, then we also know that this length is 2. And if we know that, let's just break it down into pieces. If we know that this length is 2, then we know that this length is 2 because, again, opposite sides are the same. So that means that this length is also 2 here because the whole thing is 4. That's what this 4 is telling us, that whole length is 4. So it's actually a square, not a rectangle. So the area for this top square is 2 times 2, which is 4 centimeters squared. All right, so the area of the L ended up being the area of that bottom rectangle, which was 4 times 2, plus the area of the square, which was 2 times 2. So the area of the L ends up being a total of 8 plus 4, which is 12 centimeters squared. All right, so we found the area of the L. It's 12 centimeters squared. We know the area of the bigger rectangle, which is 72. So if you want to find the area of the shaded region, then it's going to be our area of the shaded, the bigger rectangle, which is 72, minus 12, because that was the area of the L, which ends up being 60 centimeters squared. So again, if you want to find the area of a composite figure, you break it down into smaller or more basic shapes that you are aware of. And if you want to find the area of this shaded region, you would find a difference between the bigger shape in this case, which is a rectangle, and the area of the L in order for you to find the area of the shaded region.